Okay, next segment for you. What techniques are used to solve them, how you set up problems using factor label, also known as unit conversions, and checking to make sure that the units make sense. We'll go on to temperature, specific heat, and gravity another day, not this time. Alright, so when you're doing problem solving, unit conversions are always your ally because it helps you get the problem set up correctly. You should also use estimation. Conversion factors, when we are doing this type of problem, you have to realize that these are always equal to 1. One thing is equal to another. So looking at the example at the bottom of the screen, if you think about it, 1 kilometer, if you remember the definitions, is equal to 0.6214 miles. That is a ratio that equals 1. Or you can express it another way, 0.6214 miles equals 1 kilometer by putting the ratio with the 0.6214 on top. Either way, the ratio equals 1. So when you multiply a value by 1, you haven't changed the value. In this case, we're only changing the units. The goal is then to treat the units like numbers and multiply and divide them, and to set up the problem so that all the unwanted units are going to cancel. Oftentimes you can think through a rough estimate and a ballpark to see whether your work is on track. If you don't, you end up with crazy numbers and you have no idea if you've just used your calculator. So get your calculator handy as you work through these problems with me, and we'll see how these things come out. All right, one example from the textbook here that is easy to look at for an example of how you estimate says that a child is 21.5 inches long at birth. How long is this in centimeters? Well, you have to realize that you have to know about the conversion between inches to centimeters. So 2.54 centimeters per inch, okay, about 2.5 centimeters for 1 inch. So it should take about 2.5 times as many centimeters as it does your inches that you were given. So let's say approximately 20, because we don't like details if we don't use a calculator. 2.5 times 20, if you could do that in your head, maybe you can, maybe you can't, but at least you might be able to believe me that that's 50 centimeters. So you identified the given information to actually set up the problem. You would say 21.5 inches, and so you write that down here to work out the problem carefully. And I don't like English to metric, but they're useful examples. You want to come up with the answer in centimeters, so we're really only going from inches to centimeters in this unit plan. And so the conversion factor that we need here is going to be given here in step 3. We're looking at 2.54 centimeters is equal to 1 inch. So that's an equality that equals 1, that ratio. And so in so doing, we have set it up to allow the inches to cancel. And then all we have to do is plug it into a calculator. It becomes a math problem with your calculator. And with your trusty buttons on your calculator, you should come up with the same value that's shown here, 54.6. Again, considering sig figs, what would the proper value be? Well, in this case, 54.6 centimeters is a 3 sig fig value, and we had in this initial problem been given the value of 21.5. That one should determine how many sig figs we're going to have in our answer, because there is no other number in the calculation that was given to limit you. The conversion factor is an infinite. You describe that one as a defined value. It's an infinite number of sig figs, so that one won't limit you. So your 3 sig fig answer here is correct. 3 sig figs corresponds to the value of 3 sig figs that you started with. All right, oops, I should leave units in here. Put the units in. Uh-oh, the tool doesn't like me. Sorry about that, gang. Okay, next question. This one is a little more interesting. It actually comes from one in the textbook. You may have seen it, but let's work it together. The patient is going to require a painkiller that's given as 0.012 grams. The solution that contains it is 15 milligrams per milliliter. How many milliliters should be given? So what do we have and what do we need? We're going to be trying to figure out what is our starting point and what is a conversion factor. Start with a value that is not a conversion factor. A certain number, a physical quantity, a measured amount. So we're going to start with grams, and we want to end up with milliliters. Well, what are we going to do to get there? Well, you can't convert directly from grams to milliliters. The conversion factor we're given here gets you between milligrams and milliliters. And so we can use that, but that means we have to get to milligrams first. So let's go to grams to from grams to milligrams to milliliters. Start with your initial value, 0.012 grams. And now we're going to have to figure out how we get from our conversion between milligrams and grams. If you're not used to it yet, you will be someday. Grams and milligrams are commonly used in conversion. There are 1,000 milligrams per gram, and then the grams will cancel. The next step, we'll have to get from milligrams to milliliters. Well, that's where the conversion factor provided in the question is going to be used. And so we'll put in the milligrams on the bottom, and the milligrams are 15, and on top is the milliliters per 1 milliliter. So you just put the milliliter on top. You can write in 1 if you choose, but it doesn't really matter because it doesn't do anything here. And now you get out, whoops, check, make sure your milligrams cancel. Get out your calculator and see what you get. So the answer that I got on my calculator, which hopefully is the same as what you got, is 0.8. The unit should be milliliters here. Now, sig figs. What do we do with sig figs? In this question, we're going to have to evaluate how many sig figs should be in the answer. I like to just write down what you see from the calculator and then reinterpret according to the right number of sig figs. From this question, what is the limiting number of sig figs? The first value at the top here, the 0.012, that is only 2 digits, so it's 2 sig figs. Again, the 0 in front of the 1 and 2 is a placeholder. The other value is also 2 sig figs, and so we should report a 2 sig fig answer. Well, if you have 0.8, how do you get it into a 2 sig fig answer? You add a 0 at the end, and that becomes a 2 sig fig value. 2 sig figs. All right, that's another example of how we do calculations and sig figs together. Let's try the next one. Dosage problems always give people fits, so let's talk one through. So we're going to calculate the dosage. It's always amount of drug per body weight. And so you have to look at both parts and then come up with a ratio at the end to have a dosage. We're going to talk about a 145-pound adult in the US of A. We still use pounds. The person is taking 2 tablets, and each tablet is given to have an amount of 0.324 grams of aspirin. So what should we do? What we want to have is drug per body weight. And if in this type of problems, you can do it 2 ways, but I'm going to show you the one that seems to be more straightforward so you don't have to write down as many steps. So let's find out how much drug this person took. They took 2 tablets, and the amount in each tablet is 0.324 grams, and their body weight is given in pounds. Okay, so take what you've done, 145 pounds, and now we're going to convert until we get those in the units that are desired of milligrams and kilograms. To do so, we're going to have to convert grams to milligrams. That was supposed to be an arrow. That was supposed to be an arrow. Good luck. And then we have to convert pounds to kilograms. All right. Now, so it doesn't matter in which order you choose to do these conversions. Let's just choose to get rid of grams first because it's on top. So put a gram on the bottom, convert it to milligrams. How many milligrams go with a gram? If you don't know it, put it on your note card because you're going to use this one often. 1 gram is 1,000 or 10 to the 3rd milligrams. I'm just going to go ahead and write in 1,000 today. And that allows the gram to cancel, which is good. And the next step is to do pounds to kilogram conversion. Of course, you don't always remember this conversion, so it's always provided for you. I don't like it either. It's just a silly number. And 2.205 pounds will be equal to, boy, that's a very sad looking writing here. I'm going to have to learn how to improve my writing on this device. Per 1 kilogram. And when you do that, the pounds on the bottom over here cancel out with the pounds on the top over there, Their answer then becomes milligrams per kilogram. Now the rest is just a calculator exercise. So my calculator gives me a value of 9.8541. Well, that's not exactly the right number of sig figs. How about let's check this one out. The value was going to be milligrams per kilogram. And so we need to go back to the values given in the original problem to determine how many sig figs are appropriate in the answer. In the 145, that's a 3 sig fig value. That's supposed to be a 3. The 0.324 is a 3 sig fig value. The 2 aspirin tablets is a counted value, so we're not going to limit by that. And we never limit by these kinds of conversion factors. If you give enough digits in pounds to kilograms, that should be more than we have in our given problem. So we're going to go back to 3 for our answer, because that's the limiting values in the physical quantities provided in this question. So a 3 sig fig answer in this case would be 9.85 milligrams per kilogram. Now, you're going to need to use this answer in the second part. The second part asks you to calculate the dosage. Oh, maybe not this one. I forgot the question. The second question, we're trying to determine what the dosage is for a child who took 2 aspirin tablets. Well, the child obviously took too much, and the dosage should be much higher. If the child weighs 43 pounds, how much is that compared to 145? Maybe about a third as much. So the dose should come out to be 3 times the dose that we calculated for the adult. About 3 times. So let's estimate that. We don't always estimate because some of these numbers are a little hard to work with, but let's do what we can on this one. So this time we'll have 2 tablets, the same as we did before, times 0.324 grams. This is very difficult to write with today. I'm not liking this. Sorry, folks. And divide that by the body weight, which should be, this time, a funny different, smaller child, 43 pounds. So the 43 goes on the bottom. The same conversion factors will apply as we used on the first one. So set it up in exactly the same fashion. So you can see I've filled in the calculation, the conversions factors just as before. This time I just didn't do it while you had to watch me write. And so we'll punch in the values. This becomes a math problem again. And you multiply the 0.324 times 2 times 1,000. Then you divide by, you'll go ahead and multiply by 2.205. Divide by the 43 and see what value you get. My value this time doesn't look correct. I got 3.3, so I don't trust my value. I'm going to recalculate because if it doesn't look right, you should do it again. The child has taken too much drug, so let's do it again. The 0.324 times 2 times 1,000 times 2.205. Now divided by 43. I hope I get a different number. Ah, there we go. I lost a digit on the way. I had missed a 0 when I put it in the first time. So this time my answer comes out to be 33. Oh boy, sorry guys. This is a very unsatisfactory tool. I'm going to have to get a better strategy soon. 33.22 and 9 is the next digit. And so if you're going to evaluate your sig figs, which you need to do, we have to go back to the values provided in the problem again. This time we're going to go back to the problem that says 43 pounds. And we have 2 aspirin tablets. That's not going to limit us again. But the 0.324 grams of aspirin is more digits than the 43 pounds. So we're going to have to go to 2 sig figs this time. And in so doing, we end up with just a value of 33 milligrams per kilogram. There you have an example of a dosage problem. Now, dosage problems will always be frustrating because you find that you're trying to cancel out grams when you really aren't, because you've got milligrams on the top and milligrams on the bottom, or kilograms on the bottom. And so milligrams and kilograms will end up both in your answer, which does feel a little funny, but dosage problems will end up with ratios. And so a 2 sig fig answer here, there you have it. Gives you 33 for your answer. And this is not working. 2 sig figs. And that would be appropriate for this calculation. All right, next question on the next slide. One more example for you today. If a person has a normal blood cholesterol value, it should be 200 milligrams per deciliter. If a normal adult has a total volume of 5.1 liters, how much cholesterol is present? How do we set this one up? All right, so you have to look at your given values. You have 5.1 liters of blood volume, and then you have a blood cholesterol value of 200 milligrams per deciliter. We're trying to figure out how much cholesterol. I'm guessing this should probably be some kind of gram value, right? It looks like it should be. And so we'll have to decide what our starting point is and what conversion factors we have. When you see a ratio, that note tells you that something is a conversion factor. And so therefore begin with the value that is only a measured quantity, the 5.1 liters. 5.1 liters, well, how are we going to get from liters to grams? Well, using that conversion factor has deciliters, so let's get to deciliters. And then we can get from grams, well, we could use milligrams. Milligrams are sufficient. And so if we just have to pick our answer, in this case it's not specified, so milligrams makes it a shorter calculation. And we'll see whether we like the value there. Liters to deciliters, what shall we do? How many liters goes with how many deciliters? Well, if you remember the prefix for deci, deci means tenth, 1/10. So 0.1 liter is 1 deciliter. The second step then is very simple because you have it directly from the conversion factor provided in this cholesterol. So you have to figure out where you're going to put in the units so that they cancel. The deciliter should be the one that needs to cancel, so put it on the bottom. And on top we have our 200 milligrams. And our 200 milligrams per deciliter then allows the deciliters to cancel, and the rest becomes a math problem. So we're multiplying 5.1 times 200 divided by 0.1. Well, if you want to figure that one out, let's see. Let's estimate. 5.1 times 200 is about 1,000. And then if you're dividing by 0.1, you're effectively multiplying by 10. And so our answer becomes 10 times as much, so we have 10,000 approximately for our estimation here. Well, in that case, maybe we don't like a milligram answer. And so maybe we should go ahead and take that one step further because 10,000 milligrams is a lot. So let's take this down and go one step further to grams. It's an arbitrary choice here. And so how many milligrams go in a gram? I think we've talked about that one at least once today. And 1 gram is going to be 1,000 milligrams. And so put the 1,000 milligrams on the bottom where the milligrams can cancel. And from there we have the math problem. But before you hit your calculator, take out some zeros. Here's 2 zeros that you can take away with the 2 zeros on top. And now you have 5.1 times 2 on the top, which isn't too tricky on your trusty calculator. And you divide that by 0.1, which you could have done another way, but I'll leave it this way for today. And then divide it also by 10. And that comes out even, and the answer is 10.2. You might have estimated that more carefully in your head if you're good at these things, but it's all right. And so 10.2 grams becomes your answer. However, how many sig figs should there be in this answer? Write down what you see, then decide. In this question, we have 200 milligrams per deciliter as the first value. That looks like a 1 sig fig value, which is rather unfortunate, seems limiting. And the other value has 2 sig figs, the 5.1 liters. And so you pick the one that has the least number of places in the value when you're doing multiplication and division. In this case, we only get a 1 sig fig answer. So the answer is going to have to be 10 without a decimal, and it's going to be 10 grams. 10 grams. So to 1 sig fig, that's all you get in this question. All right, enough of calculation examples for today. I hope these things will help you. Good luck as you work on your assignments.